Today's day 12 of Unit 7. We started with this warm-up today, so take a moment to pause the video, work on the warm-up, then play to check your answers. So the first one, we start with the initial amount, $300, times the multiplier, which we don't know, so x raised to the time, which would be 2 days, and that's going to be equal to the 356.43. So I need to divide each side by 300. Let me pause this a moment. I need to figure out what that equals. Okay, so that gives us, I don't think I actually simplified that. I just left it as 356.43 over 300. Then I'm going to take the square root of that. And that's going to leave me with x is equal to, now really we'd have the absolute value, but we're disregarding the negative here. That gives us 1.09. So that's the multiplier. The question's asking for the percent, the daily percent. So that's 109% minus 100 is 9% increase. Number 2, or letter B, what will be the cost 3 days from now? Okay, so you can either use the now amount, which is the 356.43 times the 1.09 multiplier. And if so, then you're saying 3 days from now, so 3. Or that would be equivalent to doing 300 times 1.09 to the 5th power, because the $300 was 2 days ago. So 3 days from 2 days ago means 5 days, or the exponent of 5. So either way, whichever those I do, I get approximately 461 and 59, $461.59. Number 2. So we're going to start with the 6%. And we're going to divide that by 4 because it's quarterly, so the number of times it's compounded. And that gives us 1.5%. I add that to 100, which is 101.5%. And I change that to a multiplier. 1.015 is the quarterly multiplier. And that's it. Okay, so we did not quite finish yesterday the half-life problem, so go ahead and copy this one into your notes. We're talking about phosphorus 32, and there's the half-life, 14.3 days. We have a 50 milligram sample, and we're figuring out the half-life, or I'm sorry, the amount remaining after 84 days. So y equals the initial amount, 50, times 1/2, because it's half-life, raised to the time here is 84 days. I'm just checking to see if the units are the same, so they're both in days, so we don't have to convert anything. And we're dividing that by the half-life length, which is 14.3 days. So when I enter that in my calculator, 50 times 1/2 to the 8.84 divided by 14.3 power, I get, looks like, I'm not sure what it was before rounding, but after rounding, 0.85 milligrams, okay, which is our answer. Okay. So the rest of today, we're going to take a look at some more interest problems, compounded. And this one is 6% annual. It's compounded quarterly, and we have $200 to begin with, and I want to know how much is in the account after 2 years. So this should look familiar because we already did this in the warm-up. So we took the 6%, we divided it by 4, we got 1.5%, we added that to 100, and we changed to a multiplier, so 1.015. That is our quarterly multiplier. So now I'm going to put $200 at 1.015 for the multiplier because that's quarterly, and I'm going to raise that to the time, which remember the multiplier and the time have to match. So if this is a quarterly multiplier, which it is, then the time has to be number of quarters. So after 2 years, well, there's 4 quarters in a year, that means 8 quarters in 2 years. So that's how I set this up. So I type that in my calculator, and I am getting, and we're talking dollars and cents here, so I'm going to round right away to the nearest cent, $225.30. Okay, so then I'm asking about 6 months. So again, I started the same way, initial amount, 1.015. Remember, the exponent is number of quarters. Well, there are 4 quarters in a year, 12 months in a year. That means 12 divided by 4 is 3. That means 3 months per quarter. And if I'm asking for 6 months, 3 months is 1 quarter, which means 2 quarters is 6 months. So 2 is our exponent. Again, type that in the calculator. We're getting $206.05. So let's try the next one. So you'll notice the annual rate's the same, the initial amount's the same, the time periods are the same. The only difference is this time we're going to look at compounded monthly. So we have to get the monthly multiplier. So I start with the annual rate. I divide by the number of times it's compounded per year, which is 12. That gives me 0.5%. I add that to 100. And I change to a decimal. That is the monthly multiplier. So our equation, $200 times 1.005. And remember, because that's a monthly multiplier, the exponent is the number of months. So if I want 2 years, I know there's 12 months in 1 year, which means 24 months in 2 years. Now I'm ready to enter that in the calculator. And when I do that, I get $225.43. So same equation to figure out 6 months. But when we're entering our exponent, remember, number of months is the exponent because it's a monthly multiplier. So I just enter 6. And when I do that, I get $206.08. Okay. Now, the reason that I chose the same annual percentage and the same initial amount and the same amount of time is because I wanted to compare numbers. So looking at those exact same rate, initial amount, and length of time, and the fact that this one's compounded monthly, so we have 225.43. If I compare that to 225.30, the 225.43 is higher. So you want to think about why that is. Hopefully that does make sense to you why compounding monthly is going to produce more interest than compounded quarterly. Why, if you're not sure? Because compounded quarterly means only every 3 months will interest get added on. And remember, once interest is added on, then the next time interest is calculated, it's calculated based on the new total, which includes the previous interest that was earned. So the more often you're earning interest, assuming that the amounts are the same, the percentage and the dollar amount that you entered in the length of time, then the more often you're earning interest, you will have a larger total in the end. So both of these numbers, the 225.30 and the 206.05, should be smaller than these numbers because monthly is more often than quarterly. And they both are. So next we're going to open an account, same percentage, same dollar amount, same amount of time. The difference this time is it's compounded continuously. So Hold on a second. Did we get? Yeah, we did get both answers there. I just wanted to make sure. Yeah, we have both answers for both. Okay, so continuously, sometimes students in class thought that meant daily. Well, daily is different. Daily is just once every day. Continuously means all the time, constantly, and that's different than hourly. Hourly is not even as often as continuously. Continuously is constantly. And so with daily, let's say, we know how to calculate that. We would take the rate and we would divide by 365 because there's 365 days in a year. Well, continuously, there's nothing that I could divide by that would help me to calculate continuously because that's all the time. So the question would be like, well, what do we divide by? Well, there's a formula that helps us to calculate continuous compound interest. And that formula is y equals p times e raised to the RT power, or oftentimes we refer to this formula as PERT. So let me explain what each of those letters represents. So P stands for the principal. Principal is the really banking term, but really that just means the initial amount. So we start the equation the same way we have been starting it, with the initial amount. E, maybe you knew this, maybe you didn't, but E actually is a number, just like I is a number, and we may not have known that before this year. E is also a number, and we use the letter E because it stands for the person who discovered it. His name is Euler. That looks like Euler, but it's pronounced Euler. Euler's constant is E, which is a number, and like I said, it is a number. We'll talk about it in a second where it is on the calculator, but it is a number. It does have a value, a numerical value. So R represents the annual rate in, or I should say as, a decimal. Okay, now this R is not to be confused with the multiplier. It's not a multiplier. It's a rate as a decimal, okay, which is different than a multiplier. And T is the time in years. The time in years has to be in years. If by chance I'm asking something besides years, you have to convert those years. You have to convert whatever it is that I'm asking for into years, because with PERT, you have to use the annual rate, which means you have to use the time in years. There's no way around that. You have to do that. So now that we know what the formula is, let's see how it works. So our principal in this problem is our initial amount, which is $200. We're going to multiply that by E, and we're going to raise it to the RT power, and the R is the rate as a decimal. So 6% as a decimal is 0.06, not 1.06. A common mistake I see is for students to write a multiplier there, 1.06, and that's going to give you a really high answer. It's going to be really off. So it's the rate as a decimal, which is 0.06. And I'm going to multiply that by the number of years, which I'm looking for 2 years. So I'm going to multiply that by 2. So you should be able to type in your calculator 200 times E raised to the 0.06 times 2. Now, how do you do that? Well, on most of the graphing calculators that you have, there's a button that has LN on it, which later in the unit we'll talk about what that means. But for now, don't worry about that button itself. But what's above it, you'll see E to the X above that button. So if you want to type this in your calculator, you're going to type 200. You're going to type times, and then you're going to do second and then that LN button. And then once you do that, on your screen will pop up E, and then there'll be a spot here for you to fill in the exponent. So in that spot, you're going to put parentheses 0.06 times 2, end parentheses. So that will take 200 times E. It'll raise it to the, if you put the parentheses around it, 0.06 times 2 power, parentheses, and that's what we want. So after you type that in, you should get $225.50. Okay. By the way, if you have an Inspire, there's the actual button that has e to the x on it. So you don't have to do second and then a button. It's just a button that has that. But that's how you enter it in your calculator. So that number, if we compare to the other two numbers, is again higher, which it should be, because if we're comparing constantly calculating interest versus only once every month versus once every 3 months, and then this amount should be higher. Okay, so that should make sense. So let's get 6 months now. So we have y equals 200 times e raised to the, again, 0.06 times, remember, this has to be the time in years. So 6 months is half a year, so I have to use 0.5 or 1/2. So you can enter that. And when you do that, you should get $206.09, which once again is a little higher than the other two amounts after 6 months. Okay, that takes care of today's lesson. So you're going to work on worksheet 7, problems 1 to 5, and worksheet 8, problems 5 to 15 for tomorrow.